Reference angles and quadrant cousins with radians. First, let's remind ourselves of the rule we established in the previous video that for reference angles, it's all about connecting quadrants 2, 3, and 4 back to quadrant 1 and drawing triangles in those quadrants. And so you take angles greater than 90 degrees, which would be in quadrants 2, 3, and 4, and you reference them to acute angles of less than 90 degrees, allowing you to draw triangles. And really the algebra way of doing this was that in quadrant 2, we did 180 minus the angle. So whatever your angle was, you did 180 minus that, and that gave you that reference angle in that quadrant. You know, whatever your angle here was, you subtracted by 180, and that's how you got, you know, this angle here, and that was the reference that we would use to draw the triangle. And it was how short of this 180 line were we? Well, in quadrant 3, it's also the 180 line, but it's how much over 180 are we? And so the rule was your angle minus 180, like 210 minus 180 kind of thing. And that gave us that acute angle in there. And then in quadrant 3, it was a measure of that angle off the 360 line, and so the rule was 360 minus theta. And then, of course, in quadrant 1, we didn't need to do anything because we already had an acute angle and we could already draw our triangle. So what we should do is, knowing that we're in radians, is just change this to pi minus theta, because 180 is pi, of course, and theta minus pi, and 2 pi minus theta. So this is how you could do your reference angles in radians. But first, let's just take a look at a four quadrant, each quadrant, and how they'd be related to each other. For example, like let's start off using a acute angle of pi over 6, which of course we could convert to degrees and do things like that, but we should be pretty familiar with radians. Now, pi over 6 is one of those that you should probably have memorized, and that is a 30-degree angle in radians. But let's see, that's pi over 6. In quadrant 2, now again, just to go back to degrees for a second, if this was 30 degrees, quadrant 2 would be 150 because it's 30 degrees short of 180. And that's kind of what you need to think about this also, that 180 is pi, and so we're looking what is, pi over 6 less than pi, or what is pi minus pi over 6. And the thing is that makes this really easy is, remember, you could turn 1 into a fraction. Like I could turn the 1 into 7 over 7 or 8 over 8, any fraction where the numerator and denominator are the same. Well, pi I could think of as 6 pi over 6, which makes it really easy. And pi over 6 is 1 pi over 6. And so if I'm 1 pi over 6 short of 6 pi over 6, that's going to be 5 pi over 6. And so that would be the quadrant 2 version of pi over 6. And at quadrant 3, 1 pi over 6 more than 180 would be 7 pi over 6. And in quadrant 4, it's not about pi, it's about 2 pi. But I could think of that as 12 pi over 6, which is the same thing as 2 pi, which is my 360. And I'm 1 pi over 6 short of that, so that's going to be 11 pi over 6. And notice that they're all pi over 6. There's just 5 of them, or 7 of them, or 11 of them, but they're all references of just simply pi over 6. And so that's why reference angles and radians really aren't too bad. Like, say I was given, I don't know, let's pick a random angle here. Let's say we have an angle of, well, let me give you an angle first. Let's do 3 pi over 4. Now, 3 pi over 4, first of all, I could tell what quadrant that is, because if I'm doing pi over 4, I know 180 is going to be 4 pi over 4. And I'm short of that. I'm just short of that, so I know I'm less than 180, but I'm definitely greater than 90, because 90 would be 2 pi over 4, which is pi over 2. So I know I'm in quadrant 2 of 3 pi over 4, and it's so simple to do the reference of that, because all you really do is just take the denominator. It'd be 1 pi over 4. Because think about it. It'd be 4 pi over 4 minus 3 pi over 4 is 1 pi over 4. So a reference of 3 pi over 4 is pi over 4. Let me do another example. Let's get a quadrant 3 angle. Let's say 6 pi over 5. 6 pi over 5 is an angle in the third quadrant. And I know that because 5 pi over 5 is 180. And it's one more than that. How much more than that? Well, it's 1 pi over 5 more than that. So the reference of 6 pi over 5 is 1 pi over 5. You know, and the quadrant 2 version would have been 4 pi over 5. You know, the quadrant 4 relative of these, well, it's 1 pi over 5 short of 2 pi, which is 10 pi over 5, and we're 1 pi short of that, so that's going to be 9 pi over 5. You know, so if you think of it in terms of the 180 being 5 pi over 5 and 360 being 10 pi over 5, and you know in quadrant 1 I'm 1 short of that, so that's 4 pi over 5, and in quadrant 3 I'm 1 more than that, 6 pi, and in quadrant 4 I'm 1 short of the 10 pi. The reference angles and radians really aren't that complicated. But a lot of people shy away from them, and so what they do is they convert them to degrees and work in degrees, which is fine, but radians don't need to be that scary when you kind of understand that relationship between them.